In an earlier chapter, we learned about the least squared regression line and how to use it to make predictions. Now we're coming back to that, and we want to know how well we calculated that line, how accurate it is, how precise it is, and we want to look again at how we talked about changing 1 unit of x and how that would affect y. We want to know what is our margin of error on that. So we're going to use this idea specifically coming back to inference. So here's an example to show you what we're looking at. Here we have all 222 eruptions during a month at Old Faithful, and we're plotting the length of the eruption versus the amount of time in between eruptions. And because we're looking at all of the eruptions within a month, we're going to call this our population regression line, or our true regression line. And then we're going to take some simple random samples of these 222 eruptions and compare what our lines would look like. So here we've taken 3 separate samples of size 20, and we've come up with sample lines of best fit. So this is like our statistic versus our parameter. And you'll notice that the slopes of these lines, which is what we're specifically interested in, they range from 7.7 to 10.2, whereas our population or our parameter slope was 10.36. Just like we had sampling distributions for proportions and means of samples, we also have a sampling distribution for our slopes in our least squared regression line. And we are also interested in the shape, center, and spread of this distribution as well. So we are hoping that this distribution ends up being roughly symmetric and unimodal so that we can use things like our significance test to be able to make conclusions. And we want it to be unbiased, which means we want the center of the sampling distribution to be close to the center of the population. And in this example, they are. We've got 10.35 for the sample and 10.36 for the slope of the population line. So those are close. And we also want the spread to be as small as possible so that we can make good predictions. So now let's take a look at our big ideas. We're going to look at parts of our least squared regression line and look at the symbolism and the way we would interpret for the parameter, the statistic, and then compare those. So let's start with the slope. So for slope, for the parameter, we're going to use the capital beta and we'll do a sub 1. For the statistic, for slope, we're going to do a lowercase b and also use a sub 1. If we are asked to interpret the slope, we're going to say something like, with each additional, and we'll fill in the blank with whatever the x context is, the predicted, again, fill in the blank with whatever the y value is, either goes up or goes down based on whether the slope is positive or negative by blank amount. That's whatever your slope is. Okay, our next part of our regression line that we're interested in is the y-intercept. For the parameter, we use a capital beta sub 0 to represent the y-intercept. For the statistic, we use a lowercase b sub 0 for the statistic. And then when we're asked to interpret it, you'll say something like, when whatever x is in context is 0, y hat, whatever that is in context, is blank, whatever your y-intercept was. Now I've got 2 more parts to our least squared regression line. The next is the standard deviation of the residuals. For the parameter, we use a sigma. For the statistic, we use S. And when we're asked to interpret that, we say that the actual typically varies by blank, whatever your standard deviation of your residual is, from the predicted. And last, we have our standard deviation of the slope. For the parameter, we'll use sigma sub b1. And for our statistics, we'll use our standard error, so SE sub b1. And our interpretation is that if we repeated the random sample or assignment many, many times, so if we repeat a random assignment or random sample many, many times, the slope typically varies by whatever your standard deviation of the slope is from the true slope. And we'll end with a quick review on how to read the computer output for our least squared regression line. If you remember from chapter 3, we didn't do very many of these calculations, and it's not something you'll be expected to do, but you will need to know how to read the computer output. So this part has not changed. The value that's in the row for constant and column for coefficient, this is your y-intercept. And the value right underneath that, that is your slope. And the S value, this is still your standard deviation of residuals. But here's what's new. These last two items here. This is your R-squared value. Actually, I guess this is not new, but this was your R-squared value, or your coefficient of determination for your slope. But what is new is this one here. This one is your standard error for your slope.